prove that the operator I d by dx and d square by dx square are Hermitian. We have studied the condition for Hermitian, that is, if A is an operator and psi m and psi n are any two arbitrary function, then the operator A is Hermitian only if the psi m star A psi n dx equal to the operator A operates on this psi m function and we are taking the conjugate into psi n dx, and this will be also equal to psi n star A psi m dx the whole star. This is the condition for an operator A to be Hermitian. That is, psi m and psi n are any two functions and A is an operator. If this A is an Hermitian operator only if the psi m star A psi n dx is equal to, within this integral limit, we are operating the operator on the psi m function and we are taking the conjugate of that. Then into psi n dx is equal to this integral psi n star A psi m dx the whole star. We are taking the whole conjugate. So here given I d by dx and d square by dx square are Hermitian. So we have to prove, instead of this A, we are giving this operator first, I d by dx, and also second d square by dx square. So considering the first operator, then we can write similar to this equation, that is psi m star operator is I into d by dx psi n dx. This is the equation, and there are two functions, so we can integrate it by integration by parts. That is, it will be equal to, when we are considering the integration by parts, this can be written as, that is, integration by parts is the first function into the integral of the second minus integral of derivative of the first into integral of the second. So we are considering the first function as psi m star and this as second function. That is, according to this integral, that is psi m star d by dx of psi n, I d by dx of psi n. We are considering the integral of I d by dx of psi n. It will be psi n and I. That is, this is the within the limit. This is the first term, that is integration by parts, first function into integral of the second. First function is psi m star and the second function is this one, I d by dx into psi n. Then minus, that is integral of derivative of the first function d by dx of psi m star into integral of the second, that is psi n, into dx. We are taking the I as outside. This is the integration by parts. And here this equation, it will be 0 because the value of psi m and psi n at this point, at plus infinity and minus infinity, will be 0. So this will be 0. This value will be 0 and the remaining value is minus I integral psi m star dx. This is the second remaining value, and this can be written as, we are considering this minus I into, we are taking this minus I into the integral, that is, we can rearrange it and we can write it as according to the condition of Hermitian also. That is, psi m star A psi n dx can be written as A psi m the whole star into psi n dx. Here psi m star into, that is psi m star into the operator I d by dx into psi n dx can be written as, that is the operator A, that is I d by dx psi m the whole star into psi n dx. Then it will be, it is A is will be an Hermitian operator. So here similarly we can write, we are taking this into the bracket, that is I d by dx psi m the whole star into psi n dx. Hence this d by dx is an Hermitian operator. So we can write into this form. These two will be equivalent. So here I d by dx is an Hermitian operator. So similarly, for the second case, we can write it as d square by dx square is Hermitian. For that, we are considering this within this limit, the integral psi m star d square by dx square psi n dx will be equal to, you have to prove like this. So for the second case, here, so the first case we can say hence I d by dx is Hermitian. So for the second case, we are considering the operator d square by dx, that is within the limit minus infinity to plus infinity psi m star d square by dx square psi n dx. This can be written as, this is also for the, as in the case of first equation, we can consider here the integration by parts. And the first function will be, here the first function is psi m star, second one is d square by dx or psi n. And so integration by parts, first function into integral of the second one, this will be d square by dx square of psi n, that will give d by dx of psi n. Then minus infinity to plus infinity minus integral the derivative of the first function, that is d by dx of psi m star, and integral of the second, that is d by dx of psi n into dx. Integration by parts. And this term will be 0 because the value of psi m and psi n will be 0 within the limit minus infinity to plus infinity. So we are considering the second equation, that is, again we can also d psi n by dx, d by dx of psi m star. We are again we are considering these two different functions. We are again integrating by parts. Then we get, that is, the first function is d psi m star by dx into the second function, that is psi n, integrating. That is again integration by parts in this equation. The first function is d by dx of psi m star, first function, integral of the second, d by dx of psi n, integrating will give psi n. And this is minus negative of this one, so we can write it here, negative minus of minus, it will give plus. Integration second part, for the second part this will give, that is the minus integral of derivative of the first one, this will give, here again considering the d square by dx square of psi m star and the integral of the second psi n into dx. So this again, this will be 0 within the limit minus infinity to plus infinity, psi m psi n will be 0. And the remaining part is, this is the second part. So this equation can be written in the form, that is integral minus infinity to plus infinity, that is d square by dx square psi m star psi n dx. That is, which proves that this d square by dx square is Hermitian. This is the first two equation, that is I d by dx and d square by dx square are Hermitian. So the next problem is, show that if A and B are two Hermitian operators, C is equal to AB plus BA and D is equal to I into AB, that is commutative AB, are Hermitian operators. So if A and B are two Hermitian operators, then we have the equation. We can write it in the form of the bracket notation, that is, if A and B are two functions and psi A and B are two operators and psi m and psi n are any two functions, we can write, that is psi m into A psi n is equal to A psi m psi n. This is psi m a psi n means integral minus infinity to plus infinity psi m star a psi n dx is equal to integral minus infinity to plus infinity a psi m the whole star whole conjugate into psi n dx. And similarly, if B is an Hermitian operator, then we can similarly write psi m b psi n is equal to b psi m psi n. That is in the integral form, integral psi m star b operator psi n dx equal to integral b operator operates on psi m, b psi m the whole star psi n dx. This is in the bracket notation. And we are considering the Hermitian operators C, A, B plus B. That is the condition for the Hermitian operator. It is integral psi m star. Here we are considering the A, B plus B A. This is the operators. A and B are operators. Psi n dx. And this can be written the two separate form, that is integral psi m star ab psi n dx plus the next one is psi m star ba psi n dx integral psi m star ba psi n dx. This is the expansion of this integral. And here we are applying the condition, that is psi m star ab psi n dx will be a psi m psi n, that is ab operators ab psi m the whole star into psi n dx. And this will be, that is this equation will becomes, this can be written as, this will becomes, that is integral ab psi m the whole star into psi n dx. Okay, AB are operators. Base equation is integral psi m star psi n dx, the integral form, it is equal to a psi n dx is equal to a psi m the whole star into psi n dx. This is, that is integral psi m star a psi n dx equal to integral the operator A operates on psi m the whole conjugate or whole star into psi n dx. Similarly, here we can write it as, if it is an Hermitian, that is AB psi m the whole conjugate whole star into psi n dx. And similarly, this also can be written as, this can be written as, this can also be written as, that is, it can be written as BA psi m the whole star into psi n dx. So consider, that is, this will be equal to, therefore formatting to this equation, it will gives AB psi m the whole conjugate will becomes equal to, that is B star A star psi m star integral psi m star psi n dx plus, similarly this can also be written as integral, that is BA psi m whole star, that is A star B star psi m star psi n dx. B star A star psi m star psi n dx plus A star B star psi m star psi n dx. ബ്രാക്കറ്റിൻ്റെ ആവശ്യമില്ല ഇവിടെ. This can also be written as, that is common will be A star B star and B star A star, and this can be written as, that is AB plus BA the whole star into, then the integral psi m star psi n dx. AB plus BA the whole star psi m star psi n dx. So which shows that this AB plus BA is Hermitian. That is AB plus BA is Hermitian. That is this function, that is psi m star AB plus BA into psi n dx can be written in the form AB plus BA the whole star into psi m star psi n dx. That is, this will be AB plus BA is Hermitian. In the second part, the question is given I into commutator AB. Commutator AB means, that is AB means AB minus BA. AB minus BA. So here also we can write it as that is I into AB. That is I into AB minus BA. D is equal to I into AB. It is given. So similarly we can prove, that is integral psi m star I into AB minus BA psi n dx. Actually this one is, this is integral psi m star I commutative AB psi n dx. This will be equal to this equation. It can be written into two different integrals, that is integral psi m star I AB psi n dx minus integral psi m star I BA psi n dx. Then this can be written in the form, that is integral psi m star A psi n dx. It will be can be written as A psi m the whole star into psi n dx as per the rule of Hermitian. So this can be written as I AB the whole star into psi m star into psi n dx. And one step cut cheyiduvana. I AB psi m the whole star into psi n dx minus this also equation adupole thanne ezhudam, that is I BA the whole star into integral psi m star psi n dx. So this can be written as I star minus I. This can be minus I. It can be taken outside also. That is, it will be B star A star. AB the whole star, B star A star, psi m star psi n dx minus I. It is A star B star psi m star psi n dx. This can be written as, and this is minus of minus I, it will be plus, so it can be written as, that is integral, this will becomes A star B star, A star B star star minus B star A star. Or that is I. So this is plus I, that is plus I AB star, then minus of this B star A star into psi m star psi n dx. Or this is AB minus BA. This can be taken in the form, that is AB minus BA. This can be written as, that is integral I into AB minus BA the whole star into psi m star into psi n dx. That is AB minus BA commutative rule, that is AB minus BA, AB commutator AB, and this it can be written as, that is I into this AB, I into this AB the whole star into psi m star into psi n dx within the integration. That is this equation, psi m star I commutative AB psi n dx equal to this I commutative AB the whole star psi m star psi n dx. That is this I into commutative AB is Hermitian. Hermitian, it is given. Then the next problem is show that the operator minus I into d by dx is a Hermitian operator. So here we are considering the operator, that is the general equation is integral minus infinity plus infinity psi m star. This operator A psi n dx equal to integral A psi m the whole star into psi n dx, the condition for Hermitian. Anyway, here A is given as minus I d by dx. Minus I d by dx. So we can write integral minus infinity plus infinity psi m star minus I d by dx psi n dx. So here again we are integrating by parts. The first function is psi m star and the second function is this one. So that is for integration by parts. The first function is psi m star. The integral of this function minus I d by dx of psi n, we are considering this minus I here, d by dx of psi n integral psi n within the limit minus integral of derivative of the first d by dx psi m star into integral of the second, that is minus I into dx. This will be 0 because the value of psi m and psi n at plus and minus infinity will be 0. Then the remaining part will be, that is minus of minus plus I into minus infinity plus infinity. This can be written as psi n d by dx psi m star dx. And this can also be written as minus infinity to plus infinity, that is minus I d by dx of psi m the whole star psi n dx. That is this minus I d by dx, that is minus I d by dx is Hermitian.